This will be the fourth session. So basically, we'll continue from what we did the last time. Is that we have already constructed the queue, right? The simple queuing system. So now what we are going to continue is that I want to show you that how do we collect some of the statistics from the simulation model. Okay. Yeah, you see that I think last time I have mentioned that there's actually two major types of simulation we're looking at. One is called a virtual environment, which actually the main purpose is for the users to gain an experience of the time flow of what is happening. So they actually can experience this virtual environment either for training purpose or maybe sometimes they just let a management level people to have a feeling that what a real system will looks like in the future. Okay, by the way, what we are focused on the simulation model, I mean, in our center is mainly called an analytical model, analytical simulation, meaning that the purpose is for collecting the data, okay, generated by the simulation to analyze on some problem, to answer some question or making decision. Okay, so this is our purpose. So the capability of collecting the statistics has become very important for our simulation model. Okay, so how do we do that? Okay, so if you look through our simulation model, actually, I think you may identify one like a specialties is that all the events here actually is a parameterless. Okay, there's a no parameter for the events. Okay, so if you like corresponding to what you see from this graph, you see that whenever we trigger something, okay, it's actually called arrive, happen, okay, load or start or finish. You let this event to be invoked, but you do not really like telling them that okay to do some things about what. Okay, but you see that sometimes when we really come up with a system, the experience of individual like load inside the system will be important, or rather than experience, let's say the track record, okay, of the individual loads flowing inside the system will be important. For example, I mean, if you like have some experience in industry that usually people will ask, I mean, have this terminology about the cycle time, okay? What is the cycle time mean? For a user, for maybe a person, a customer, the cycle time can be the time he enter the system until they arrive, until the time he finish, okay, having everything and leave the system. So this will become a cycle time. Then cycle time sometimes will become a very important criteria, okay, to judge the performance of the system. For example, if they process something, the cycle time will be smaller, will be better. Okay, so this is one thing. Another terminologies you may heard about is like waiting time. Okay, waiting time. For example, in the port, usually we're looking at this so-called a burst on arrival rate. So what does this mean? Meaning that the time between the uh, arrival and the berthing. Okay, so whether the berthing happens at the time of arrival. So in that case, actually, we are looking at a waiting time, okay, when they arrive until it's a start process, something like this, okay, if you like compare to a queuing system. So you can see that the arrival time is the arrival time of the vessel, the bursting time, the bursting time of this specific vessel. So in that case, you can see that the tracking of the parameter of the load will become a very important, okay, for simulation analysis. So that's why when we run a simulation, we actually need to like pass certain things, okay, I mean, throughout the different events. So we are able to track that when this arrival happens, so whether this arrival of the first client or second client or third client, then when we start and end, we also need to see that whether which client actually we are talking about. Why this tracking of the load is also important here is because sometimes the sequence might be different. For example, if it's the first come first served queue, then somehow we can ensure that the sequence of arrival is the same as the sequence of the starting. Okay, these two events they actually follow the same sequence to executing the load. But the thing is, if you look at the start and end, we if the capacity of the server is more than one, is larger than one, we cannot guarantee that they follow the same sequence. Probably like some nodes start later, okay, but it may end earlier because the processing time is smaller in that sense. So in this case, we can see that the tracking of the loads will become very important. Okay, so that's why we need to, the first things I want to show to you is that how to parameterize the events, okay? Then eventually that we can actually record those information in the parameter, okay? So first, let's do these things. I want to like just as simple as add an index of the loads, okay, to the event. So if it's arrive, so we check that whether it's a first or second or third load, the start and end we follow the same. So in that case, we can let's just simply do this. We add one parameter called index to each of the event, okay. So start and arrive, we know that which is actually index of this load. Okay, then you can see that after we adding these things, there's something we need to revise to the rest of the part of the code. The first one is when we schedule some things. Okay, when we schedule some things, we cannot just put the name of the event here, arrive with nothing. Yeah, because what is required is actually arrive with certain parameter. But here, if you say schedule something without the parameter, then the program cannot interpret. Okay, what does this mean? What kind of event? How do you want me to schedule the event? So what we are going to do is something like that. Instead of this arrive, so what we are going to do is have this bracket, then this equal arrow, then here we see the index, okay, is 0. Okay, so this is some things we can put, and this syntax, I think now you just need to remember, okay, that when we schedule in this structure. So on the left-hand side, it will be this bracket equals to nothing, yeah, equals to something, and on the right-hand side, this is something is actually this event, but you need to specify what are the values of this parameter, okay, when you schedule it. Okay, this is important. If the event is with a parameter, when you schedule it, you need to specify which parameter, which is a value of the parameter. Yeah, so this one is index because it's only one like parameter, so we can also like remove this index, so it will have the same effect. So we need to see that the first at the constructor, when we construct the model, the first event we are going to schedule is with the parameter 0. Just a little bit about this structure. Okay, so why this is so? Okay, so this actually, if I'm not wrong, it's called a lambda expression in C#. So basically, it's meaning that this is actually a method. Okay, so this is actually a method. So I just want to add a little bit to see that previously. So actually, what we are writing is in this way. Okay, is this way. Okay, right? So this way actually is equivalent as this one. Okay, so what does this mean? It's meaning that we're actually schedule this kind of this action. Okay, actually this is called a delegate, but I think I don't need to remember this sophisticated terminology, the name, but just imagine we're actually schedule an action, okay, in the list, in the future event list. So this action meaning that when you want to invoke this action, you need to provide something, and we will get something written back. We'll do some things written back. So what is written in this way is that when you invoke these things, there's nothing you need to provide, okay? Then after that, I will do something for you, okay? By calling this array bracket, okay? So this is what we have last time. This is what we have last time. So when you provide nothing, when we schedule things, we also need to take nothing, then it's fine. So I just need to like remove everything here, then this will be good enough. It will have a same effect. But now it's a difference. When we schedule these things, okay, so one of the things we're going to schedule is we will require you to provide nothing, okay, but when we execute, we actually execute with some parameter setting, okay, so this will be different. So why this is necessary is that the parameter, or maybe just remember this sentence, this is a statement I'm going to make now, is that the why we need to write these things is because the parameter passing to this event is set at the time it is scheduled. It is not, the parameter is, the value is not set at the time it is executed. Okay, let me repeat this again. It's because we are doing it this way is because a parameter setting is done at the time it was scheduled, but not at the time it is executed. So in that case, when we schedule it, we need to set the parameter value here, and we need to we need to convert this thing to a parameter list, okay, actions, okay, in the future event list. Okay, so I hope this kind of explanation is clearer for you, but do you have any questions for this? So you're okay with it, right? Yeah, Xinju. Sijie, yeah? Are you okay with this?
Well, just now you're saying that this is the same. Just now you put another line on top, right? So actually, I'm quite noob in this programming one. So what's the difference between a arrive bracket with a 0 inside and without a 0 inside?
Okay, so this is actually another thing that is when we have the events. So if this thing is without the parameter, so meaning that, okay, let me see this thing. Let me call this arrive one. Okay, so arrive one. So if it's not with a parameter, so it meaning that when we execute this parameter, we don't need to. When we execute this event, invoke this event, we don't need to passing anything inside. Meaning the execution of the event is independent of anything. Okay, it's independent of anything.
Okay.
Or maybe we should say that it's dependent only on the current status. Okay, it's only depends
Okay.
on the current status, which are all the dynamic properties that here and all the maybe the static information. It only depends on this part of information. Okay, but if you're passing a parameter, meaning that the execution of this part depends on what is passed in.
Okay.
This will be important. Yeah, yeah. So this will be the difference. But the thing is that this information we passing, whether it's a passing at the time it's executed or passing at the time it was scheduled, this will be different. So the reason we write in this way is that we want the setting of this parameter to be set at the time it was scheduled, so that we set the parameter first, then we schedule the whole thing, okay, to the list, so that this whole thing become parameterless. This whole thing become parameterless. Yeah. So I think this is the reason. Okay. So yeah, I think this is one of the most difficult concept in O2DES when the people say scheduling, why you write in this way. I mean, the short answer I can give is just remember the syntax. Okay. So everything start with an empty bracket. By now is that I take this opportunity to tell you what is the reason behind it. Yeah.
Okay.
Yeah.
Okay. Thank you.
Okay. How about the others? Xinju, just now you unmuted. Do you have any question on this? Or Joyce?
Yeah, I have a question.
Yes, please.
So what's the difference between because last session then the just schedule arrived, then this time got a bracket arrow. What's the difference with those bracket and without those bracket?
Okay, let's say that last time when I schedule on parameterless events, right? I write in this way, right? This is what I write. This is what I wrote last time, right? So I will say that this one is equivalent to this thing. So I did not go into the deep because this concept is a little bit complicated. But I should say that from the execution of simulation perspective, these two are the same. Okay, so this one meaning that you are actually scheduling this event, okay, which require nothing parameterless, okay, to the event. Here, actually, I'm trying to say that I'm constructing another delegate. I'm trying to construct another action. So the action is we are taking nothing, then call this a method which require nothing, okay. Then instead of schedule this one directly in the future event list, I schedule this whole things, okay, in the schedule in the future event list. So eventually it will be the same. These two statements will be the same. Or maybe you just think that this will be equivalent in a sense of the simulation modeling. I'm not saying the program wise is the same, but it just I mean in terms of the simulation modeling, these two are the same, have exactly the same effect.
Okay, thank you.
Okay, yeah, so that's why, because of this, you can see that from this one to this step will be straightforward. Previously it required nothing, but now it requires something, so I need to set a value to it now. Okay?
Excuse me, sir.
Yes.
Sir, you said like it will be in the whatever we keep in the schedule, it is for the future event list. So
Yes.
okay, fine.
Yeah. Okay, so
Okay,
actually there are two times. One time is schedule, the other time is execution. It will be two different times. But
okay,
sometimes it can be the same simulation clock. Yeah, but sometimes it can be different.
okay,
Okay.
fine.
Yeah.
Yeah, thank you.
Okay. So if no other questions regarding this part, so Xingzhu, do you have any question just now?
No.
Okay. Yeah. Hope it's clear for you. Okay. So yeah. So after this, let's continue. So you also see that there's some other arrows. For example, this is a start. So you can see that what this start is mean. Actually, it will have the. I mean, this one meaning that if the server have the sufficient capacity, then you need to start processing something. Process what? Process the load, which are currently arrived, right? Which are currently arriving. So in that case, we need to do the same thing. Bracket start. But what is inside this start? Someone can tell me?
Index.
Index, yes. So which meaning that whenever passing are passed to the start events. Okay. Okay, then we come up with this arrive. It's the same thing. When we have arrive, when we schedule something, we also need to put into this structure, then give a parameter for the arrive. But what is this arrive? Someone can answer? Will this be index again?
Index plus.
Yeah.
Yeah, index plus. Better to be plus one, okay? Because if the index plus plus, meaning that you are changing the value of the index. But now is that we do not want the value of index to be changed, but we want to create another integer and pass to the next arrive event. So that's why it should be index plus one. You see the difference of these two, right?
Yes.
Yeah. Okay. Yes. Okay. So now we finish. And now if we write in this way, it will be very clear. I mean, compared with the code last time, because last time when we see just say the start and arrive, we do not really know that which customer are you talking about. Okay. But now it will be very clear. The start is actually the same customer, the same load, but arrive will be the next one. Okay. So this is clear now. So moving forward, I also want to like put this index into the message I print out to indicate that which is actually the loads we are currently arrived. So that's why here we can put arrive, we put a arrive number, then we put an index here. Okay. So that when we execute the program, we're actually observing that, keep tracking of which load is actually going through this event. So the same things we do for the, so this one is okay, right? Okay, then we move to the next one. Okay, so I think by now, if you have any question, feel free to interrupt me. Okay, so here,
Sir, I have a
yes,
question.
please, yes,
Sir, I don't know whether it is relevant now or not. Like
yes,
previously, Prof. Lee mentioned that uh, we had a future event list quite heavy. So, so, but here, when we see in O2DES, so it is just one event after another event. So for this, we do not have the future event list problem because we in schedule we are just giving one event and we are mentioning the index also. So
yes, of course, yeah. So because this is just a first tutorial, so the example we are using now is very simple. So that's why if you look at the number of events here, it's not very heavy. Okay, but in other cases, for example, if you consider more than one server, so it meaning
okay,
that how many server, then you will have a how many future event list. I mean, probably this is actually the scale. So in that
okay,
case, consider in maybe in like the PSA, our port, how many keyframe we have, how many AGV we have, and how
okay,
many containers, I don't know, how many yakrins we have. So I think
yeah,
at least will be hundreds of them. So in that case, will be hundreds of the future event list at least. Then in that case, how to store those future event list, how to sort them, or whether we need to use a subcomponent to like a modularize to
okay,
decompose the list into a smaller structures will become a very important issue for the simulation computational efficiency. Okay.
okay, okay,
Yeah.
okay,
I
okay.
hope this explain your query.
Partly
Okay.
understand, maybe going forward we'll understand.
Sure, no problem. Just remember that this is actually a simple model. Okay,
Yeah,
so when
yeah,
the problem increase, then yeah, we will have a lot of but how to manage the future event list, I think don't need to bother too much. So
yeah.
these ones will only talk about when we go into the architecture. But now I think the purpose for this training is for you to be able to build a model. Okay, but how to execute it, we'll let the computer scientist to handle it. So don't need to worry. Computer scientist, the software architect, okay, to look into those issues. So don't need to worry. I mean, for
Okay,
you.
sir.
Okay. Yeah. So after that, we go to the start. So will be the same thing. Whenever you start, then you want to end the same thing, right? So in that case, this is schedule will be the. Someone can tell me what is the parameter here?
Index.
Index, right? Okay. And nothing changed. Here is the start. I also want to put these things index here. Okay, so now we move to end. Okay, so when we move to end, then it will have a problem. So when we start, okay, so which object, okay, which load we are going to start next? Okay, so I put the structure first, then we discuss what is the problem. Okay, so we need to put something here, right? Is this right? Is this right?
No.
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 Why? Is it because
He left already.
you can, yeah, you left already. You cannot start the same index, but which number should you use? Can it be index plus one? Probably. I mean, if the number or the server capacity is one, then we can do that. But if the server capacity is more than one, probably the next one already started, right? So how can we do this? Okay, yeah, so we need to create a queue. Okay, so let's do it in this way. In that case, we actually need a structure for us to remember what is inside. So we need to have a queue of the integer. So here, instead of saying queue, right, because queue is actually a C# standard library, the data structure. So I put this as a pending list. Basically, just a queue. Okay. Slice as empty integer. Okay. So here, you see that this one is server capacity is sufficient. We have vacancy. Then we start to do this. Otherwise, okay. Otherwise, we will add. We will need to add this index into this pending list. Right? This is what we are going to do. We need to add this one into the pending list. Okay. Okay. Then here, if this the number of queues is larger than one, meaning that there's some things are waiting there. There are something are waiting there. So what we are going to do is we need to pop up the first elements from this list. Okay. Then we start it. Okay, let's do it in this way. We start the first element of this appending list. Okay. Then we schedule this event. So this part is okay, right? This part is okay. So this will be correct. It's because we're getting the first one within the queue. So we execute it. No, we schedule the start event of it. Okay. Then after that, we also need to do something, which is actually to remove this one at 0 space. Okay, so I hope this is clear to you. And also, I think you need to understand how this list is the data structure of this list. So because this is a list, so meaning that whenever you add something, you actually add to the end of it. Okay, you actually add to the end of it. Okay, so for example, when you add it already one element. Okay, so when you add it, so this element is actually at a position of 1. I mean, the previous one, the first one is 0. So the second one will be at 1. Okay. If you add another one, it will be 2. Okay. So this is actually how we index those elements in this appending list. Okay. So this index actually is a index of the load, index of the client. It's not the index in the list. I think this will be a different index. Okay. So because of this is a list, so when we get the first element from the list, so this element will always be the one arrive earliest in the list. Am I right? So this one you can understand, right? And also after this one, the first is a query. Then we need to remove it. So that's why we actually have this remove at 0. Okay. So let me ask a question. So what we do if we set this one as the last? Okay. Then instead of remove at the 0, we need to remove at the pending list dot count -1. So actually this index of the last element in this pending list. So if we do so, what is the difference compared with the first way? Which one is the first come first serve?
Sir, we should go in by the first way because queue is first come first out.
Yes, yes. I mean, if it's a first come first out, first come first serve, then we should use first, right?
First one.
0 is used what
Yes.
the previous to have. But if we're
Yes.
implementing in this way, so it's become the first come last serve case.
Yes, sir.
I mean, it's the same as using a stack. But I mean, here we don't talk about the stack. But I
Mhm.
mean, some of the queue, it might happen. It might happen. I mean, if these things is not the, how to say, it's not the human, okay, it's not man, it's not person, but rather it's kind of the some product which are actually in the same series. So I mean, the same batch. So in that case, it doesn't really matter which one process first. Sometimes, I mean, it will be more convenient just to get the last one. For example, the container. Okay, for example, the container. When we are using this queue as a stack of container, and also the sequence of container doesn't really matter. So
Yes.
in that case, we should implement in this way. Okay. So
Okay.
this meaning the container at the top. This one meaning remove the container at the top.
Okay.
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 Yeah. So sometimes this is still valid. There's no right and wrong, but the important thing is based on the assumption. Okay. So now let's assume it's a first come first served queue. So that's why we should do it in this way.
Okay.
Okay. Yeah. So when we execute the end, we also have the same thing. Is that we put this index in to end the current index. Okay. So the end is actually meaning this part. Okay, so now let's run the program again. Okay, now let's run the program again. Got some problem. Sequence contains no element.
So I
Interesting.
have one question because
Yes.
you initially you pass in the constructor you pass the index as 0, arrive 0, right?
Yeah.
In front, but then how it increases because we haven't set any part to increase.
Yeah, actually, it's here.
Oh,
Every time
but
you arrive a new arrival, is use a current arrival +1.
but then the index itself. Never
The index
mind. Yeah,
itself
let me think.
doesn't change. Yeah,
Okay,
I mean the
okay.
value of the index doesn't
Okay.
change, but they
Yeah.
use the index +1 to construct another index, another integer, and pass to the next event.
Let me think. Okay, okay, okay,
Yeah.
okay.
So let me see what's the problem here. I think this is the first time we encounter this kind of problems. So this one arrive in the queue, yes, and another arrival start another arrivals. Yeah, but why this one? Why this one is not there? Ah, okay. Okay, so actually it's because when we schedule it,
Is it because no one in the pending list?
yeah, I think the pending list is called 2 times. Ah, okay, understood. Yes, sorry. I think I made some mistake here. You see that? Okay. So actually this is a problems of the scheduling event. Probably I think you may encounter something similar in the future. So you see that when we schedule these things, okay, when we schedule these things, this appending dot first bracket is not processed. Okay, this is not processed, but rather the whole thing was stored in the future event list. This whole thing is stored in the future event list. Okay, so after we schedule this, then the element is removed. So at the time this one was triggered in the future event list, okay, then the pending list is already empty. Okay, so I think this is a problem. Okay, let me repeat again. When you're doing this as scheduling, the whole thing, this whole thing is stored in the future event list without executing pending dot first to see that what is the value of it. Okay, so that's why when this one is called, when this one is retrieved and executed, the pending list is already empty because immediately after the scheduling, but not executing this part, then the element is removed. So at the time when this is executed, this become empty again. It already become empty already. Okay, so this will be the problem. So the way we solve it is that we need to get the next one, next to start. Maybe we call this a next to start. We let this one to be pending list of first. Okay. So we let this one to be the value first. Okay, maybe we can do this after this. So if we change in this way, I think the problem will be solved. What is the difference is that this pending list of first is executed, okay, before it's actually scheduled, okay? So in that case, when we remove, it will become safe. Then when we schedule, we just schedule, put this one as a value, so no problem. We need to process this now rather than we need to process this query now at the time of scheduling rather than the time of the execution. Okay, so in this case, let's do this one. We can see it's a successful. Yeah, I think thank for the bug. I mean, in the future, if you have encountered the same problems, then yeah, it's actually you can refer to the similar reason. The thing is, trying to make when you schedule something, trying to make the things inside as simple as possible. Meaning that I mean the simplest way is that it will be only the parameters I mean constructed locally. Okay, yeah. So don't use those parameters. So those are like global, I mean the class level properties, but use the local variables here. Okay, you process all the things before you pass this parameter to the events. Okay, I think this will be a simple principle to follow. Okay, so if you look into this result, exactly the same as the last time. The only difference is that now when we have certain like end and start, we know that which actually is referring to. For example, if you want to look at the performance of the second load, so what we can do is, for example, here, the second load was arrived 220. Okay, then at 3:1, it's got started. Then got a 4:46, it got ended. But I think in between, you can see that you got another like end event. Okay, so if later you set a capacity of the servers equals to 2, then you can actually see that a lot of the event actually mixed together. So without really have this the index of the loads, it really cannot differentiate when they have a start and end, which one actually is referring to. So now it will be clear. So from this timestamp, if you generate this one into Excel file, then you are able to, easy to track that for each like load, what is actually the cycle time of it by just like sorting based on the index, then later just do some operations. Okay, then you actually can, is able to calculate a lot of important information we require. Okay, but now is that we're going to tell you that how to use object, okay, to do this automatically in a C# program instead of output these things into Excel and do some processing. Okay, so but before that, do you have any questions here? Okay, so this part, is it okay for you?
Okay for me.
Okay, so if no problem,
Okay.
yeah, thank you. So if no further problem, so we move further. Okay, so now is that we are only passing an index. So the index, the problem is that it will be actually difficult to record some of the information in a sophisticated structure. For example, we need to record arrive time, start time, and end time. Then in that case, you can see that, okay, so we need to set another list of structure to indicate all the arrival time. We need to have another list of the time for all the starting time. It's a little bit complicated. A better way is applying the principle of the object-oriented programming to abstract, to encapsulate arrival time, starting time, ending time, all as the attribute of the load object. Okay, so this will be a better way. Okay, so how do we do that? We need to create a new class. Okay, here we call it load, or maybe a customer. Okay, for this case, let's call this a customer. Okay, so we'll see that one customer, the first is I think not necessary now. Okay, I think the first thing we need to do is to see that what are the attributes we want to trace, okay, for each of the customer. So we need to have arriving time, starting time, and ending time. For example, now we need to have this 3 times stamp. Okay, so this timestamp will be date time. Okay, because actually the time point. So we actually have let's call this time stamp for arrive. Okay. Then the similar things, we have timestamp for start. Doing this way, the timestamp for start event, and the timestamp for end event. So just briefly talking about the naming convention. When we have those public properties, so what we can have is a different word, which the first word will be always capitalized. Okay, but sometimes I also have this underscore. I think this is a kind of the personal kind of the habit. I'm not quite sure. Maybe later we need to check with Riza. Okay, so in some sense, if I say this is a word, but actually this is actually a kind of the subscript. I mean, when you have a mathematical notation, this is all timestamp, but this is a timestamp for arrive event. This is for start event. So usually I like to use this on the underscore here. Okay. But by the way, I mean, if you write in this way, also correct, but not to do in this way, small letter. Okay, so if it's a public property, meaning if this one is a public, always use the capital letter. And also don't do this. Okay, this one meaning that this is actually private, meaning cannot access from outside. Okay, so by default, let's use this one. So now we need to have a and also the index also will be important. Okay, will be integer index set and get. Okay, so here is instead of in the model, okay, instead of passing the index throughout the simulation, we change this one to customer as what we defined just now. Okay, we need to have a customer. Okay. So here you can see the difference is that this customer, I use a capital letter. This one we use a small letter. Why? It's because this is actually a local parameter. When we passing, this is a parameter. This name is only used locally. I mean, refer to all the code in between. And this parameter, this customer will be different from this customer. Okay, this will be different from this one. If it's small letter here, actually it's indicate all the things which are only within this scope. Okay, so for all the parameter passing, this name is only used in this scope. Okay, but this customer is actually a public class type. Okay, so this customer type is the same as a customer type here. Okay, and also the same as here. So this is something you can see. Later, I'll also show you the highlight when we complete this program. So instead of passing just an integer, here we are actually tracing all the customers, okay, throughout the program. So in that case, the first one, in the constructor, instead of arrive with the integer 0, what we are going to have now is we need to create a new customer here and setting the index of this customer to be 0. Okay, so this is actually the first change we need to do. Okay, we need to create a customer with index 0 and passing to this arrive event. Then in this arrive event, okay, when the capacity is enough, what we are going to do is just passing this customer, okay, to the next event. You see that this customer is the same as this one, so that's why this is highlighted. Okay. Otherwise, we're adding the same customer which passed in. Customer passed in. Yeah. Oh, sorry, I made the name wrongly. Should be customer. Okay, to the list. Okay, but just now is that how to rename a parameter in C# is that you click this one, then you press Control and press R at the same time 2 times. Okay, Control R and R. Okay, press 2 times. Then you see that all the parameter, the same parameter will be highlighted. This is also a way to check that this name, where is the scope. Okay, of this parameter. So you see that the tree is actually highlighted. So whenever you change, is that this all the parameter, the places where this parameter is mentioned will be changed at the same time. Okay, so you don't need to change them one by one. But I also see an error here. Why? It's because this appending list last time is actually created as a list of integer, but now it seems that we need to change a type of the list to be an integer of customer. Okay. So this is some of the change we need to do. Okay, then here, what should we do? The same is that we need to create a new customer, but now this integer, no, this index will be a new index, right? For this a new customer. But what is this a new index? We need to get the index of the current customer and the +1. How to get that? It's access a customer object which are passed in dot index, okay, which actually to access the index properties of this customer and set this value, increase this value by 1, not to increase this value, but +1 to get another integer and set as a index of the new customer. Okay, so this is what we need to do. Okay, then here instead of just an index, we just change this one to customer customer dot index. Okay, so wow. Okay, so this is what we need to change. Then the same things for here and here. Okay, then similarly here the start, we just need to end another the object, the customer object. Okay, which is same as this one. And also for here next to start. So previously this was an integer, but now automatically you change a type to customer. Why? Is because here we use a variable, okay, var, use a var. So this var meaning the data type of this one will be automatically adjusted based on this thing. So just now we change the type of pending list to be the list of the customer. So that's why this first become the customer. So that's why the data type of the next to start will be changed automatically. So you didn't see any error here, okay? But the data type actually changed. Okay, so now we can actually complete this one, the program. Then let's run. It actually show the same thing, okay? But now what is the difference is that we can actually record the statistics, some of the information, okay, from the simulation model into the object. Okay, so for example here, arrive, what we can do is beside just the output, this value. So what we can do is we can set a customer dot arrive time span underscore arrive equals to the clock time. Okay. Then similarly, we do at here for the start event, we can set the customer dot timestamp start, okay, to be the clock time. Okay, then similarly, let's do here is that we let a customer dot timestamp end to the clock time. Okay, so in that case, I mean, if you run a program, it will still show the same thing. But now it's actually bear in mind that all the information is actually collected and arranged according to the customer object. Let's just do one more things, okay, to say that, okay, now I want to archive all the customers who have completed the process so that later I can query for those customer, I mean, kind of the conduct a survey after they finish all the process. So here I call it archived, or maybe I just make it simple, processed list. Okay. So what we are going to do here, is only for those loads who have ended, okay, then I will add them into this processed list. Okay, customer. Okay, so yeah, because I did not output anything, so now it will be very difficult to see that. I mean, from the simulation result. So let's just create another like a helper properties here for us to query what is inside this process list. So let's do in this way. I want to have a output to see that how many minutes, okay, how many minutes of the cycle time that maybe let's say what is the average? Let's rearrange a question. What is the average cycle time for each for all the customer who has processed, meaning that have completed this any event. Okay, so this will be averaged cycle time. What we are going to recall or return for this one is that, okay, we just need to return all the customers from this process list, and we trying to average their cycle time, okay, in a way that each customer, we do these things. We get a customer's finish time minus their arrive time. So this will become the cycle time, right? Okay. Then for this time span, because this is actually one daytime minus another daytime become a time span. So we want the time span to look at what are the total minutes. Okay. So I want to average on these things. Let me just explain a little bit what does this statement mean. Okay, meaning that for this list, so it will actually the list of the customer. We want to take an average, but you may ask a question is, how can you average the average of the customer? Okay, because customer is actually an object. The average of a list of object, what does this mean? Okay, so that's why I want to create a mapping to map each object to a value that can be averaged. Okay, so for each customer, which value I'm looking at? I'm looking at the end time minus the start time and take the total minutes. Okay, so actually this is what it means. So in that case, we can map a customer object to a value so that I can average on it. Okay, so this one called this is actually the same as the lambda expression I just mentioned to you. Basically calling a mapping relationship. Okay, it's indicate the mapping relationship. And here this average is the link query, okay, of the C#, which actually is the average operation instead of just say you add all of them together divided by the total number. So you just need to use the average. The thing will be done. Okay, so this will be average time. But you can see that here you are returning double value. So sometimes people looking at this does not really know whether this is the hour or minutes. So I think the better to put this as a time span. Okay, then eventually after the average minutes, we need to convert this thing back to the time span. So time span dot from minutes. We get this whole things convert back to the time span. Okay, so in that case, it will be a very important or interesting things we can do is after run the summation for 1 hour, we can actually query what is the average cycle time. Okay, but when we print out, we need to print out this as a total minutes. So we just want to print out the whole thing to see that, okay, now is the average cycle time in minutes is this one. Okay, done. Let's see what is a result. Okay, it's actually saying that average cycle time in minutes is actually 3.64 minutes. Okay, I think to make it more user friendly, it should be the average cycle time just comma. Then here we'll see minutes. Okay, let's do it this way. Okay, you can see average cycle time is this one. Okay, any question on this? Okay, if no, I will continue to show some to just come up with some other like statistics. Okay, we're going to look at. The first one, the simple things is actually a total number of loads processed. Okay, so basically it will be integer. So I see the total number processed. Okay, so this one basically we can just return the process list and see that how many are inside. Okay, so this one will be simple. Okay, to see how many are in the list. So similarly in the program, let's see we do in this way. How many processed? Total number processed. Okay. So the totally will be 17 processed, and this is the cycle time. Another information we may be interested is actually what are the average waiting time. Okay, so what we are going to do here is we can simply copy this part. Okay, then we see that average waiting time. How to get a waiting time? We simply use the starting time minus the arrive time. So we just do this a simple change. Okay, so we can actually get the waiting time, but we sorry, waiting time. Then in the program, we also need to do these things. Average time, average waiting time. Okay, you can see that this is actually the average waiting times we have. So one of the interesting things is that if you use the average cycle time minus average waiting time, so how many we have? It's roughly like 2 minutes, right? It's roughly 2 minutes. So this time will supposedly it will be the average service time. So let's see what is average service time we are setting here. Well, it's 3 minutes. Okay, so probably let's run the simulation longer to see that whether the service time will be converged to this 3 minutes time. Okay, you can see that when we take a difference between the average cycle time and the average waiting time, we are approaching the 3 minutes when the number of process increases to 369. So this actually according to the analytical result of the queuing theorem. So if you're interested, you can do some analysis on this. For example, you can compare with the Little's law, looking at arrival rate, yeah, you're looking at arrival rate, the average number. Maybe that one I'll talk about later lah, if you want to look into the average number in the queue and also the cycle time, etc. And also if you want to look in apply the queuing theorem of the like GG, no sorry, MM1 or MMNQ. So you can also apply the equation of rho P or something lah. So yeah, looking at the arrival rate and the service rate, you can actually calculate and use the simulation model to approve what is derived from the theory is actually true. Okay, so these actually are some of the interesting things you can go to explore. Okay, so yeah, I think hope this is clear for you. Any questions? It's
No.
okay, right? Okay.
Questions are here.
Yeah. Okay. So I think okay, because I think now we already achieved 1 hour session limit. So I think I will end the content now. But before I finish, I just want to talk about one thing is the statistic we are now showing here is actually how to say is currently I don't have a name for this thing. Maybe later you can help me to see that what is a better name for this. It's actually a load driven statistics. Okay, so what does this mean is when we want to see how many okay, for example, you see the average waiting time. So average on what? Average on the list of the load, average on the list of the client. So eventually you see that all those things will be looking to the individual performance of the load because each load actually have a waiting time. Each load have a cycle time. So what we are going to do here is that we need to collect those individual piece of information from each load. Then we need to aggregate those information, okay, at the system level to get either the average or we get certain percentage or percentile, for example. But this a percentage, percentile, the average performance were based on the individual load that are passing through the system. So this will be a one type of the statistics. So that we need a load structure, a load object to help us to collect the information like all the timestamp we are collecting now. Okay, is like a customer is this information we're collecting now. But we actually have another type of the statistics. Okay, for example, the things we are showing here, how many processed. Okay, so I think, and also for example that what is the average number in the queue, or maybe another thing is what is the average number in the system. Okay, so if you see that the difference between these two types of the statistics is that for this number, when you see the 369, does it really matter that whether this 369 is a customer, is a product, is a load, whether it's actually have a cycle time, waiting time, those things does not matter. We just simply count. Okay, we just need to simply to count the number, and also in some cases that this number will change from time to time. For example, if we want to look into average number of the what is average queue length, something, you can see that queue length is actually dynamic from time to time. Okay, but if you want to look into the time, the average queue length is actually meaning that we need to integrate. Okay, we need to integrate the length of the queues on time in order for us to calculate the average. Okay, so this average will be average on time rather than average on the loads, the number of the loads. So these are two different, very different statistics we are actually collecting from the simulation. Okay, probably later you can help me to do some searching literature review to see that what is actually a better words for this two time. Basically, let me just make it simple. Is what is the average on time? For example, average queue length, average number in system. So if average on time, the other thing is actually average on the number of loads. So this will be a very different two types of the statistics. So today what we have talking about is actually the second time. Those statistics need to be average on loads, the number of loads. But for those who will need to average on time, we did not touch for this session because of time limit, which we're going to talk about in the next session. So in that kind of case, we need to use the statistical tool called the hour counter. Okay, so this is actually one of the important things I want to introduce to you in this training. Okay, so I think with this, we will end today's session. So basically today we have analyzed the one type of statistic, and we show you how to parameterize the events, and yeah, we look into how to parameterize the event. Sorry, where is it? Yes, here. And also is that how to like let this a parameter to be an object and use this object to trace individual statistics, and eventually we look into their average. Yeah. Okay. So I think with this I will end the session today. Okay. And
Okay.
any last question? If no, then we can.
Hoping I have one question, but not with regards to this. Is with
Yes.
regards to Friday's training. Do you have
Yes.
any instructions for those participants for Friday? Anything that need to tell them beforehand to prep or anything?
I think probably no lah. Probably no lah. I think
Okay.
basically I will repeat what I had in this session,
All right.
and also I want it to be an introductory course. So in that case, not much preparation is required.
Okay.
So just for those who want to have the hands-on experience, so what they can do is after my introductory, they can actually watch a video, then repeat what I did.
Oh,
Yeah.
okay. Okay, sure.
Okay.
Oh, yep. Okay.
Yeah, I hope you have a question
Yes.
about the lambda expression. The still the schedule event. So if there is no input for the event, so if there is input for the event, just like today's case, then
Yes.
can I remove the bracket in front? So just schedule, arrive, blah blah blah.
Cannot. Okay. You cannot do these things. The reason is because it's actually a explicitly constrained that this is a schedule. After a schedule, they need to have an action. Okay, I think this is actually a technical term. Maybe you need to know if you want to really zoom into this concept. You can only schedule an action. So what is the action mean is that action is a delegate. Okay, action is a delegate. A delegate is what? Is a method without a parameter. It's a pointer to a method without parameter. Okay, so these are some of the technical terms. It need to be an action, and by definition, the C#, the action is a delegate. Delegate actually meaning a pointer to a method without a parameter. Okay, so if you're doing this way, so what is the type of this? The type of this will be the returning type of the arrive method. So you see this arrive method, returning type is void. So the type of this thing is void. Okay, but what is required is an action. So you cannot put in a void to an action. Okay, so this is why there will be an error. But if you do in this way, the lambda expression actually gives you lambda expression is actually a delegate, okay, which actually creates sorry, I think just now I made it wrong. Okay, I made it not that accurate. Is okay, I write it here. Action, okay, is a delegate, okay, meaning that a pointer to a method. Okay, so what is this a method? Is what is this a method? So each method actually have a signature, okay, which meaning that you have the input parameter and output parameter, right? So this a delegate also the same thing. So delegate if it's a pointer to the method. So this method will have a input parameter of nothing, empty, and output parameter as void. Okay, so action is a delegate, meaning the pointer to a method, which input is non-parameter and output is void. Okay, so this is actually an action. So action is required for scheduling. Okay, and if you see what this lambda expression is given is this lambda expression is creating a delegate. Okay, which the left hand side is input. The input is nothing. It's right. The output is a void type. Okay, yes, it's right because arrive something is void as defined here. Okay, so this is correct because this actually give you an action. So this actually by definition. Yeah. Joyce, is it okay for you?
Yeah, okay for this question.
Yeah.
But how about the the line 39? Then this one is still lambda expression, right? Average customer what
Yes. It's
30
a
sorry,
yes.
yeah.
Mm.
So uh so this one, then the left hand side is not nothing anymore, right?
Yes. Because what is required by average, this method is not the action. Okay, this average, whatever inside the average inside this bracket here, okay, inside this here is not action. Okay, so if you like a mouse over, you can see maybe just press half of the bracket. You can see what is taken in is actually a function mapped from customer to double. So this is what is required by the average. Okay, so that's why in between this actually something creates what the average wants. So basically the idea is that this is actually a method. Schedule is actually the method. So average, this method requires something. This schedule also requires something. What schedule require is actually an action. So which need to empty in, void out. And what this average is required is a function inside, and this function is something in and a double out. So here we need to make sure there's something in and the right hand side is double. As long as the right hand side is double, then the left hand side is actually the same type as inside this list. Then it's fine. This is a requirement of the average.
Okay. Yeah, I think it clarifies. Thank you so much.
Yeah. Mm. Okay, so I think really if you want to look into this topic, which I do not suggest the learner of this tutorial to go through, is reading the C# programming language, the delegate, and there's a several type of a delegate. One is called a function, another one is called a action. Okay, function, action. Then the other one is a predict. Let me see whether it's a predicate. Predicate. Okay, predicate is actually a delegate which will return a boolean. I think these are some things you can read. Yeah, I think function, action. Yeah, okay. Then action also have a template type. They actually have a action, which means that there's no input. You can also see an action of something which actually you allow some input, but the output will be void. So action, function, predicates are all delegates. Under the C#. So I think this is some things you can read more if you really want to see that what are the syntax, why the syntax is so. Okay, Ken?
Okay, thank you.
Thanks.